Hello students, welcome to the class Mathematics. In the last class, we discussed some of the problems in the chapter set theory. Now in this class also, let us discuss some more problems. Shall we start? Okay, let us start now. Now let us see this first question. Let X be the set consisting of the first 2018 terms of the AP 1, 6, 11 and so on, and Y be the set consisting of the first 2018 terms of the AP 9, 16, 23 and so on. Then the cardinal number of the set X union Y. To find n of X union Y, there is a formula. First let us write. That is, n of X union Y is equal to n of X plus n of Y minus n of X intersection Y. With the help of this formula, we can find the value of n of X union Y. But here, n of X is nothing but the number of elements in the set X. But we can very easily tell that n of X is equal to 2018 because X is the set which contains 2018 terms. That's why very clearly n of X is equal to 2018. And in the same way, n of Y is also 2018. Here Y is the set which contains 2018 elements. That's why both n of X and n of Y are equal to 2018. Still we have to find n of X intersection Y. To find the cardinal number of the set X intersection Y, first we must know the elements in the set X intersection Y. For that, we have to find the set X. Given that X is equal to set of 1, 6, 11 and so on 2018 terms. And also given that in the set X, all the terms are in AP. So, with the help of the nth term of an AP, we can easily find the last term of the set X, that is 2018th term. For that, we need the values of A and D, where A is the first term of the AP, that is 1, and D is common difference, which is T2 minus T1, that is 6 minus 1, 5. Now we can find A 2018, that is 2018th term in the set X. For this, the formula is A plus 2017D, which is equal to 1 plus 2017 into 5. If you simplify this expression, you will get 10,086. So, the last term of the set X is 10,086. In the same way, let us find the set Y also with the last term. Here given that Y is equal to set of the elements 9, 16, 23 and so on. 2018 terms here also. How we have calculated the 2018th term in this set? Here also, in the same way we can find 2018th term. For that, first term A is 9 and a common difference D is equal to 16 minus 9, which is 7. Now, A 2018 is equal to A plus 2017D, which is 9 plus 2017 into D. D means here 7. After simplifying this numerical expression, you will get 14,128. 14,128. Students, now let us write the sets X and Y with their last terms. That is, X is equal to set of the elements 1, 6, 11. Of course, here let us write some more elements to get the common elements from both the sets X and Y. So here in X, as the common difference is 5, let us write some more elements by adding this 5. So to get the next term, you have to add 5 to 11, 16. 16 plus 5, 21 plus 5, 26 plus 5, 31, 36, 41, 46, 51, 56 and so on, and the last term is 10,086. And in the same way, let us write the set y also. So y is equal to set of the elements 9, 16, 23. Here the common difference is 7. That's why 23 plus 7, 30, 30 plus 7, 37, 44, 51, 58 and so on. The last term is 14,128. Now let us take common elements from both the sets x and y to get the set x intersection y. So here if you observe, 16 is the first common element. The next common element is 51 is there. So 51 is the next common element. So here also you can get the common elements which are in AP. That's why here as the common difference is 35, we can write the next term as 51 plus 35, that is 86 and so on. But here we have to find the last common element. With the help of the nth term, we can easily find the greatest common element for these two sets x and y. That's why here a is equal to 16 and the common difference d is equal to 51 minus 16, that is 35. So a plus n minus 1 into d must be less than or equal to, here the greatest term is 10,086, here the greatest term is 14,128. That's why for these two sets the greatest common element must be less than or equal to smaller element only. That's why of these two, what is the smaller element? 10,086. That's why the common element for these two sets x and y must be less than or equal to 10,086. Now let us substitute the known values in this formula. That is a is 16 plus n minus 1 into d is 35 is less than or equal to 10,086. After simplifying this in equation, you will get n is less than or equal to 288.7. As n is the whole number, the greatest value of the n is 288 only. 288. So it means we can understand that n of x intersection y is equal to 288. Now we can easily find the value of n of x union y. Therefore, n of x union y is equal to n of x. N of x means there are 2018 terms plus n of y also 2018 minus n of x intersection y that we have got now, that is 288. If you simplify this numerical expression, you will get 3748, that is 3748. So this is the value of n of x union y. Students, shall we see this problem now? If a is equal to set of the elements 2, 3, set of 4, 6 and 7, then the true statements of the following. The first one is set of 2 is a subset of A or not. Let us see. But we know that if a set is a subset of the second set, the condition is each and every element of the first set must be present in the second set. So by this, let us see whether all the elements of the first set are present in the second set A or not. Here, what are the elements in the first set? There is only one element, that is 2. Let us see whether 2 is present in the set A or not. Yes, 2 is present in the set A as an element. That's why as all the elements of this set are present in A, we can say that the first set is a subset of second set. That's why this relation is true relation. The second one, set of 4 comma 6 is a subset of A. Here also let us see whether the elements 4 and 6 are present in A or not. Here, can you find the elements 4 and 6 in this set A? No. But here set of 4 6 is an element. But here we have to conclude that the elements 4 and 6 of the first set are not present in the second set A. That's why this set can't be subset of set A. That's why it is false. Next, set of 4 6 belongs to set A. So here we use the symbol belongs to when the first one is present in the second set as an element. Let us see, set of 4 6 belongs to A is true only when the set of 4 6 is present in the set A as an element. Let us see, here clearly we can see that set of 4 6 is present in the set A as an element. That's why as a set of 4 6 is an element in the set A, we can say that this element belongs to set A. That's why it is correct usage. This is correct relation. Now let us see fourth one. This is set of 3 comma 7 belongs to A. It can be true only when set of 3 comma 7 is present in set A as an element. Can you find set of 3 comma 7 is present in A as an element? No. That's why here this statement is false statement. And the last one, a null set is a subset of set A. But we know that null set is a subset of every set. That's why this statement is true. So like that we can easily verify whether one set is subset of second set or one element belongs to set. Students, now let us see this question. Write the power set of A, that is a set of 1, 2, 3. We know that the power set is nothing but the set of all the possible subsets of the given set A. That's why first let us write all the possible subsets of the given set A. First here we know that null set is a subset of every set. That's why it is the first subset. Next, let us write the subsets with single elements. So what are they? Set of 1, set of 2, set of 3. With the single elements we have written. Next, let us write the subsets with 2 elements. So what are they? Set of 1, 2, set of 2, 3 and set of 1, 3. Next, let us write the subsets with 3 elements. Of course, in the given set there are only 3 elements. That's why the set itself is the subset of A. That's why A is a subset of A. We know that every set is a subset of itself. That's why here we can take A as the subset of A itself. Now, these are the possible subsets of the given set A. Now, if you take all these elements in one set, the set of all these possible subsets is called power set of the set A. It is denoted by P of A. So, this is the power set of the given set. As we have got this situation, let us discuss the number of subsets, the number of proper subsets and the number of non-empty proper subsets. Anyhow, we have a formula. If the set A has n elements, then it can have 2 power n subsets. That's why here, as the set A has 3 elements, the number of subsets of the set A is 2 cube. Therefore, the number of subsets of the set A is equal to 2 cube, that is 8. Anyhow, we have already counted 8 we have got. Next, the number of proper subsets of the set A. Here I am writing the number of proper subsets of the set A. Number of proper subsets means except this A, remaining all the subsets are called proper subsets. Okay, that's why here how many proper subsets are there except this A? There are 7, that is 2 cube minus 1. That is general formula 2 power n minus 1, that is 7. Next, number of non-empty proper subsets. Let us write the number of non-empty proper subsets of A. Number of non-empty, it means those subsets should not be empty. That's why we have to neglect this 5 also. Now this time you have to neglect these 2 elements from the total number of subsets. What is the total number of subsets? 2 cube. Now for this non-empty proper subsets we have to neglect 5 and set A also. That's why you have to neglect 2 elements, that is 6. So like this we can find number of subsets, number of proper subsets and the number of non-empty proper subsets for the given set. Students, now let us do this problem. Let S is equal to set of the elements 1, 2, 3 and so on 100. The number of non-empty subsets A of S such that the product of the elements in A is even is dash. Now students, for this set S, now we have to find the total number of non-empty subsets with the condition that the product of the elements in all the subsets is even. For that, first let us write the total number of non-empty subsets of the set S. So here I am writing the number of non-empty subsets of S is equal to, as the set contains 100 elements, we can say that 2 power 100 minus 1 non-empty subsets will be there for the set S. Now in all these 2 power 100 minus 1 subsets, the product of the elements is either even or odd. But we know that the product of the elements is odd only when all the elements are odd. That's why first let us find the total number of the non-empty subsets in which the product of all the elements is odd. After finding this number of non-empty subsets, if you subtract this number from this 2 power 100 minus 1, in the remaining subsets, the product of all the elements will be even. Then it can be the required number of non-empty subsets. Do you understand, children? Now let us do the same. First of all, you tell me how many odd numbers are there in the set S. It is very clear that there are totally 50 odd numbers. Now by using all these 50 odd numbers, how many non-empty subsets of S can we write? We can write totally 2 power 50 minus 1 non-empty subsets of the set S. So let us write the number of non-empty subsets of S with 50 odd numbers. 50 odd numbers is equal to 2 power 50 minus 1. Now let us subtract the number of all these subsets from the total number of subsets. Therefore, the number of non-empty subsets, of S such that the product of the elements is even is equal to 2 power 100 minus 1 minus of 2 power 50 minus 1. If you open the bracket, you will get 2 power 100 minus 1 minus 2 power 50 plus 1. Minus 1 plus 1 get cancelled. Then here you will get 2 power 100 minus 2 power 50. If you take 2 power 50 common, then you will get 2 power 50 minus 1. So 2 power 50 into 2 power 50 minus 1 is the required number of non-empty subsets of S such that the product of the elements in all the subsets is even. Students, now let us do this problem. If A and B are two sets where n of A is less than n of B and n of P of A plus n of P of B is equal to 1025, then the cardinal number of the set B is. So here it is very clearly given that the number of elements in A is less than the number of elements in B, and also n of P of A. P of A means the power set of A, which is nothing but the set of all the possible subsets of the set A. So n of P of A means the number of subsets of the set A plus the number of subsets of the set B is 1025. Then you have to find n of B. For this, first let us write the given conditions. That is n of P of A plus n of P of B is equal to 1025 and n of A is less than n of B. First let us know about n of P of A. For that, let us consider the set A. A is a set and the number of elements in the set A is denoted by n of A. Then n of P of A, that is number of subsets of the set A, is given by the formula 2 power n of A. So here also we can write n of P of A as 2 power n of A plus n of P of B as 2 power n of B is equal to 1025. Now let us see the value of 2 power n of A for a different number of elements in the set A. If the number of elements in the set A is 0, then the number of subsets of the set A is 2 power 0, that is 1. If n of A is 1, then the number of subsets of the set A is 2 power 1, that is 2. If n of A is 2, then the number of subsets of A is 2 square, which is 4. If n of A is 3, then the number of subsets is 2 cube, which is 8, and so on. Now, if you observe all these cases, except in the first case, in the remaining all the cases, number of subsets of the given set is even only 2, 4, 8 and so on. But in the first case, what is that case? When the number of elements in the given set is 0, number of subsets is 1. Now let us take this case. In this case, sum of these two numbers is 1025, which is odd. But we know that sum of two numbers is odd only when one of the numbers must be even, the other must be odd. That's why here of these two numbers, what can be the odd and what can be the even? For that we can use this condition. Here given that the number of elements in A is less than number of elements in B. That's why here we can say that the first number must be odd, 2 power n of B must be even. Therefore, 2 power n of A must be 1. This implies 1 plus 2 power n of B is equal to 1025. This implies 2 power n of B is equal to 1025. This plus will become minus 1 here. Then it is equal to 10,024. Then 2 raised to the power n of B is equal to 1024 can be written as 2 power 10. Therefore, n of B is equal to 10. Students, now let us see this interesting problem. Here if A1, A2, A3 and so on A30 are 30 sets, each having 5 elements, and B1, B2, B3 and so on Bn are n sets, each with 3 elements, such that union of all these sets, 30 sets A, and union of all these n sets B is equal to S. If each element of S belongs to exactly 10 of set A's and exactly 9 of the set B's, then the value of n is. For this, first let us take the given conditions. What are they? Each of the sets contains 5 elements. Let us write n of A1 is equal to n of A2 is equal to and so on is equal to n of A30 is equal to 5. And in the same way, each of the set B's contains 3 elements. That's why n of B1 is equal to n of B2 is equal to and so on is equal to n of Bn is equal to 3. And also given that union of all these 30 A's is a S, and also union of all these n sets B's is equal to S, which means union of all the sets A's and union of all the sets B's are equal. That equal set is denoted by letter S. Now let us find the number of elements in the set S when all the elements in the sets A's and the sets B's are completely different. Now if all the elements in the sets A's are completely different from one another, how many elements will be there totally? As there are 30 sets and each set contains 5 elements, we can say that 30 into 5, that is 150 elements will be there in all these sets A's. And in the same way, in all these sets B's, how many total elements will be there if all the elements are different? As there are n sets and each set contains 3 elements, we can say that there will be totally 3 into n elements if they are all different. But it is given that each element of S belongs to exactly 10 of A's. What does it mean? If you take any element in the set S, that element exactly belongs to any of the 10 A's, which means that element repeats 10 times. So here if each element of S repeats 10 times, what is the total number of all the distinct elements in the set A's? For that we have to divide this 150 by 10. Then it will give the total number of distinct elements in the all the set A's. And in the same way, each element of S belongs to exactly 9 of the B's. So what does it mean? Each element of S appears any 9 B's. It means each element of S repeats 9 times exactly. Now, what is the total number of distinct elements in all the sets B's? For that, you have to divide this 3 into n by 9. Now, these two numbers will be equal, which is n of S. Now, by solving this equation, we can easily find out the value of n. So, for that, first let us simplify. 3 ones, 3 threes, 0, 0. It means 10 ones, 10 threes. Now, to find n, we have to transpose 3 to other side. 3 into 5 into 3 is equal to n. Therefore, n is equal to 15 into 3, 45. It means the value of n is 45. Okay, students, in this class, we have discussed some problems from the chapter set theory. Okay, let us discuss some more interesting problems from the chapter set theory in the next class. Thank you.